Hey everybody, this is Larry. This is August 21st, 2024. Yeah, and here I am, well, waiting for the loading screen, but also trying to do an algorithms problem that I have not solved on Leetcode before, as soon as it finishes loading, which is a problem that I haven't solved before yet either. Hope everyone's having a great week. The weather here in New York has been kind of cool, which is nice for my running. So hopefully, it'll stay that way for a little bit. I guess it is end of August. Boy, has the summer kind of gone by quick. Let's hope for a little bit of a easy problem. Because I don't know, I'm feeling like I need some sleep, but it is loading. Loading. All right, today's it is a hard problem, but hopefully it's not that bad. So 428 serialize and deserialize N-ary tree. Okay, I mean we know what serialization means. Oh, you don't have to do this format. So basically, you're just trying to, I guess, give a string that gives you something to convert back or something, right? The height of the tree. Do not use. Oh yeah, of course. Okay, yeah. 100. The node value doesn't really matter. Okay, and this is of course not a binary tree, so. And I don't know that does the order of the children matter. Okay, yeah. Okay. So there are a couple of ways you can think about doing this. Do it with a depth first search, either implicit or explicit stack. Yeah, and I think that's probably the way to go. An in order representation, or maybe you could do post order. I guess it doesn't really matter. There's no wait. Did I say in order? I meant pre-order. Sorry, you could do pre-order. I think it's probably the way that I would do it. So let's do that then, right? So then now we go. The key thing though is that you don't return. Like you have to be careful about. You have to be careful about concatenating strings. I think that's the biggest thing, right? So here maybe we just have a buffer, right? That we just kind of do as we go recursively, and then we just kind of yeah. How do we do it? Yeah, just like. I'm trying to name it, and it's just hard. So sir maybe of a node, right? So then here, if node is none, then we return and maybe we will follow their format just because I'm a little bit lazy, but because you can't look at that, it's just like beginning and the end, right? So that means that so the node is not none. So then now we can start off by the buffer. We append the left thing, the auto complete. This kind of, and then at the end we buffer. We append the right thing, and then in the middle we want to buffer append integer of node dot value, and then now for child in node dot children. Yeah, we just serialized child, and I think that's pretty much it, really, right? So then here we do a serial of the root, and then we can return to the join buffer. Yeah. How do I test this? Okay, I mean, it's not that I don't know how to test this, but it's just that I want to test this without, I want to test this separately from the deserialization, which I guess that's what they tell you. So yeah, maybe I could just print data, return none. Maybe that lets me kind of just take a look at the serialization. Okay, so integer found. Oh, whoops! Of course, I meant to convert this to a string, not to convert it to an integer. But yeah, okay. So is this accurate? Oh, this is this tree? 1, 2, 3, 3, 6, 7. I think this is pretty accurate. So yeah. So yeah. Yeah, it looks good to me, really. So then now you can do this with a stack, right? Yeah, you could do it with a stack. You can maybe actually do this recursively as well, actually. So then now you have the current buffer, which is the data, and then you have like the buffer or data index or something like this. We'll just call it index is equal to 0, right? And then you, I guess I'd rather do it in implicit or explicit stack, only because I think it's. No, that's not true. I guess I could do it this way. DC. Right, so then here, this assumes the first character is a Yeah, I mean, I think this is fine, I guess. So then, yeah, so if data of index is equal to well, maybe we have to assert this, right? So we assert that this is true. So then now, I guess we have to do this first. So that this is true, then we increment by 1. I guess the tricky thing is that we have to do the number parsing, which is a little bit awkward, which I didn't consider. I mean, we can also change the way we do the thing, right? Yeah, let's add a delimiter, so that we always return something no matter what, maybe an exclamation mark, right? So this just allows me to let's just return none for now. So then now what it does is index our oh, am I doing returning 0 or something? Why would this I mean, the output is. Oh, I didn't print it. Well, let's print the data here, right? Because this is the thing that maybe is giving us issue anyway. Yeah. So the I don't know why this is. Maybe is there like an empty? Oh, case 3 is empty. So we might have to think about how to do this one, right? Because this now fails this part, which I guess is true, but it's kind of weird, honestly. Because then maybe we just do like if length of data is equal to 0, we just return none, right? I mean, I think that's a more reasonable thing to do it, because I don't know. Because this already, because I think I want the precondition to be this. And then now, the reason why we put an exclamation mark is just so that it's easier for me. I mean, I think, yeah, it's just easier for me to parse until the thing, right? So then now we have parse value, right? So then val is equal to 0. And then while data index is not equal to exclamation mark, then index we increment by 1. But before we do that, we add this to, we shift, and then we add this to data index, right? Something like this. And then now that means that data index is equal to, so then we have to consume it. And then now, yeah, and then now the next thing can be whatever. the next peak. So if data of index, if this is equal to this, then we're done, right? Or maybe first, if it's not equal to this, then now we have to do a recursion, right? So if it's not equal to this, then in theory, it should be the open bracket. So maybe I do something like while this is true, we discern this is because this thing also consumes character. So in a non-local way, it's a little bit confusing to read though, but yeah. Oh, I don't really do anything with this yet. What is the node definition? So okay, so yeah, so here maybe we have node is equal to node, right? And then yeah, and then node dot value is equal to value, and then here we have node dot children append deserialization, and then we just return node. That should be good. Oh well, and then now data of index is equal to n bracket ideally, so we actually should assert it, right? And then if that's the case, then we can consume this index as well. Should be okay. All right, looks good. So yeah, I mean, we get to define the language. It makes it a lot easier. I think, oh, okay. That's good. I was going to say if I left it out in the data thing, so we can definitely remove this for a little bit more performance. I was going to say, just a little bit more. I was going to say that if I had one thing that I would worry about is like degenerate cases. But maybe there are no degenerate inputs. Like, I don't know. The thing is that if we get to define a serialization, like we just come up with serialization that doesn't have degenerate cases and just easy to parse, right? And that's why I have this exclamation point, so that it makes it like even easier, right? We just read until it. Because in theory, the next character that is not an integer could either be a right bracket or I guess a left bracket, because this also asserts that this is left. But now that we add an exclamation point, we don't have to worry about it. We just kind of do it this way. Of course, I wrote it all in one I wrote it all in one function, so it looks kind of messy. But ideally, you can also like just put these in a helper function. So maybe even put this in a help, like get children or something like this. Just to make it a little bit easier to read, but also to unit test, right? But it's Leetcode, so for now I'm okay. So yeah, let's go. And the serialization should be pretty straightforward. It is just, like I said, recursive. Pre-order traversal. Yeah, I wonder if post-order is easier. Maybe post-order would have been easier. No, I mean, I guess it's the same, because then now you do this, and then you check whether the next character is a thing to go. Either way, it doesn't really matter, I think. Yeah. That's all I have for this one. I didn't go with complexity. I mean, this is linear time, linear space, both lower bounds, because this is the size of the linear space is the size of the thing, and linear time is you have to look at each node once, right? And we only do that, so that should be fine. Yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to good mental health. Wow, this was a 15-minute video. I'll see y'all later and take care. Bye bye.